Hey everyone, welcome back. This is Raju from Smart AI Technologies. Today I'm going to demonstrate you a project called crop yield prediction using machine learning for Indian agriculture. So in this video, we are going to see multiple stuffs. First of all, we'll understand what is mean by agriculture crop yield prediction, why it is needed, and what are the issues that are leading to the loss of the farmers in the crop yield. So how this crop yield prediction will gonna solve that problem. So we'll discuss each and every topic one by one. Then we'll move to the research R&D part. So there in research and development part, we are going to see multiple IEEE papers which are already published. So from each paper, we are going to do research gap finding. Then we are going to see when whether we can propose our methodology and what are the methodologies that we can provide or propose, and what is the impact of our proposed methodology on the result. So all those things we'll see, because if you are students and if you are trying to write any research papers, IEEE are like that, you need all these stuff. You need clear methodology. It is not just a Python code that runs. So you need reasoning why you are selecting, if you are selecting something, if you are doing pre-processing in a particular manner, why you are doing it, because each and every process in the data science can be done in a multiple ways. So if you are selecting some technology, any particular technology, why you are selecting and how it gonna improve. So if you make the project in detailed way, then only you can publish a paper, and as well as you can present it in a better way for your externals and so on. Even when you do all these research oriented stuffs, it is very easy for you to present it to the interview process. So in the interview process, if you mention them, so you've done so much of research, and then the implementation, you will be having a positive side. Before moving further, first we will discuss, and then once we study the paper, then we'll see our application, how we built, what are all the things that we integrated here. So we have a home page, and you can navigate here. You can see that basic information, what are all the basic information it will provide, what are the pre-processing data, what is mean by EDA data to model data, and test the application. And once this also done, I will be showing you Jupyter notebooks. So where we built the models, where we built the multiple models, where we implemented and we done a lot of R&D over the data set. We done multiple codes, because each technique that impacts on the accuracy and the loss, especially mean square error changes. So all those things are clearly mentioned. So everything you can tabulate them. So first experiment, second experiment, third experiment, it is not one time Python code. Okay, just take a data set and make a coding and then get a result. It is a complete project, complete R&D over the problem. So first we will understand about the introduction of this project. So what is mean by crop yield prediction? The quantity of crops that will be harvested from a specific field and region. What if you can able to predict the future yield of that crop based on the historical data, on the soil information, weather information? So it will be having a positive side. So you can plan for that. And why is the crop yield prediction is needed? What are the reasons? One is resource optimization. It means under this it will come allocate resources such as water, fertilizer, and pesticides efficiently. And then risk management. The potential threats are mainly like this. What do you say? Uh, Pest and weather. Mainly pest and weathers are the most important stuff. So changing weather and attack of the different pests will cause the problem. So you can manage this if you can predict the result. And after that, market forecasting. So you can assume what will happen with supply levels, okay, making it easier to plan for the pricing. All those things can be done. So that is the need. That's why we need to go for future crop yield prediction based on the historical data. For example, let us say you are from Lucknow, and in the previous year you got particular amount of crop yield done. Then comes sustainable farming. So within this, you can precise, if you find out the precise yield prediction, what type of things you can decide is that soil health can lead into the long-term benefits. This is the most important stuff. All these are most important features are the results. For example, if you can able to predict what will be the crop yield in the future, you can decide the things better. It may be under research optimization, it may be under risk management, it may be under market forecasting, it may be under sustainable farming. So under sustainable farming, how the quality of soil will be staying for a long time. That means how long you can grow a crop in a better way, and what are all the key features that impact on a crop yield, maybe loss or maybe profit. So one of the feature is climate condition. Changing climate condition leads to the crop maybe better growth or loss, maybe over rainfall, or there is a drought. Okay, there is a increase in humidity, maybe there is a high wind blowing. So that also causes, these things are the reason for the problem for the crop yield. And soil quality is also the most important stuff, because when you grow something in a particular land, for example take paddy is such a crop which needs lot of water. So in that case, in paddy fields, the water will be incoming and after some time it will be leaving the soil. So when you are keeping that water for a long time, it will be absorbing almost all the nutrients faster than the normal crop. So when you leave that water out of the field, it will take everything outside, maybe nutrients and even some chemical components, maybe that sprayed over the plants, that also will be taken away. So the soil will be losing its content faster in paddy condition. So the soil is the most important feature again. And then comes pest and disease outbreaks. So these are sometimes unexpected, and they will cause a lot of impact on the crop yield. They will destroy the whole farming itself, especially pest and some diseases, which it's very hard for farmers to find out in the early stage what is that, and when they are trying to find out, the whole thing will be destroyed, the whole crop will be destroyed. That also will happen. That's why pest and disease outbreaks will happen. They will cause the crop yield prediction loss. And type of farming, what type of farming you are practicing, and technologies, what type of technologies are being used in the farming. And market access and economics. So under market access and economics, the amount of produced but also be ability to sell the crops in favorable prices. So here the decision need to be taken, what amount of crop is grown, what price it should be sold, whether it will be profitable or not. Because when supply and demand, okay, supply amount and demand amount, so these are the main key features. So that's why I say market access economics is also the impact. For example, there is a need for 2000 tons, but in the market there is already 4000 ton. So in that case the crop value will be reduced because demand is very less, but you are having a lot of supply. Here there is a lot of amount of crops, sorry, agriculture product is available with you, but there is no demand for that. In that case the price will go down. What if the demand is very high? It means that region may need around 5000 tons, but you are having only 2000 tons. In that case the price of the crop will be increased, or crop product will be increased. And then how can machine learning help farmers with the crop yield? So data driven insight, it means based on the soil temperatures and satellite imagery, they can understand what will be the scenario, whether it will be having any drought or like condition or any loss in the crop yield. And then predictive modeling, so based on the soil condition, that's what our project is mainly. So our project comes under predictive modeling. We are going to build a model which can able to say what will the possible yield in that area based on weather conditions, that is temperature, humidity, pressure, as well as soil parameters, npk, as well as what type of soil it is. So these features. So based on these features, if we can say what is the possible yield, that comes under predictive modeling. And early detection of problems, maybe pest or disease or nutrient deficiency, using technologies will solve the problem. And precision farming, specific needs of the crop. So what is that crop and what it needs, not randomly spraying the thing and wasting the chemicals and losing a lot of money there. Yield forecasting tools. So real-time updates and yield forecasting tools which can give farmer about maybe pricing and all those stuff, that also can help the people. These technologies can help farmers to overcome the problem. So one among them we are taking is ours is model predictive modeling technology. So is AI changing our agriculture? Yes, it will almost change the agriculture, the way that we grow and the way that we sell. Because again, the above points only will be repeated, because precision agriculture and smart irrigation system, automated machineries, predictive analytics, okay, and climate change adaptations. According to climate change, the farmer will need to change the crop itself instead of going against the climate and feeling like, okay, I will go with the same crop, whatever the climate around me is, not staying not saying like that. And you need to change crops according to the changing climate around us. That also lead to the profit. Now we've gone through the introduction of our project, that is most needed stuff, because sometimes we try to skip them. We need to reason, we need to give the reason why we are doing, if we are doing something. If I'm taking some topic for my research, maybe a final year project or a MTech or a PhD research, why I'm taking, what is its importance, and whether if I do R&D over this, will it be helpful for me in future, and what's the impact of this R&D over the society. So all these questions will be asked whenever you take up any title. So you need to know the introduction, whatever I try to explain, or you can collect so much of more data and numbers also you can collect, maybe how much grown in which city, which area, and like that. If you present in detail, so you can able to present things clearly and it will be accepted. Now we are going to discuss about the existing system of multiple papers. So we have around 4 IEEE research papers. Now we need to check them one by one and we need to understand what is there in that paper. For example, let us take the first paper, crop prediction using machine learning. So crop prediction using machine learning, this paper, what are all the things it contains? So existing system, what is the existing system of this paper? Then I will say you what we are trying to propose in our methodology and how it is impacting on the result. So all those things I will show you one by one. The first thing this paper presenting is that they collected various datasets from Kaggle, Google Weather forestation and government databases, and then they optimized the data, okay, and they used soil nature climatic conditions as a feature, and the dataset is from 10 years. So this is a clear information about the dataset that they are using. And what are all the data pre-processing they are doing? They are gonna do missing value, and then they're gonna extract necessary functionality from the raw data. It means again it is a feature extraction. It means they are gonna extract the information, not exactly features for input and output. They're gonna say, for example, there is a one column which may not be related, they'll make it relative column. The pre-processed data is implemented in Google Colab. They are using Google Colab for that. So this is the one part. And when it comes to feature selection, it means what are the most important feature that gonna impact on the better result. What they are doing, they will reduce the dataset size by extracting the key features based on what? Based on the correlation matrix. So their idea is very simple. They are doing it on correlation matrix. Here is a challenge. So we need to find out the research gap. That is our task. So correlation matrix. So how impactful this selecting some features based on the correlation is. Is it much impactful? We need to do coding. We done that. We take a data set, we do whatever they presented here, then we'll improvise it step by step. Okay, correlation, feature selection using correlation is not good. Then what I can do? So then what I can propose? Okay, if I am proposing some other methodology, say your wrapping technique. So then we code for wrapping technique, whether that is giving good result or not. If not, we go for some other lasso regression or like that. So we try multiple stuffs and then we try to prove that we can do feature selection better than this by going with some other techniques than the correlation matrix. So that we proposed in our model. And they are speaking about the models down. Okay, the final training data. Yeah, they split the data training and test and validation. That's fine. Okay, so mainly they concentrated on the naive bias and naive bias Gaussian classifier. So they are not going to multiple models. They feel like only naive bias can do the stuff. No other model can, because they are concentrating on only one paper. They are saying, okay, this model, this is giving this much result, and this is our R&D result, and this is best result. They will be proving that in the existing system of their paper. That's why they are allowed to publish the paper. So now, so here there is a lot of research gap needed to be filled, because we can't say some model that was better than other model without implementing multiple model. So in our case, we are going with the multiple machine learning models to prove we can get better results than what this paper is getting. And this and the next paper is this crop yield prediction based on the Indian agriculture using the machine learning. So what does this paper say within that? So normally this paper is mainly dedicated for the literature survey. It means this paper is going through multiple research papers and they are trying to find out what they done. For example, when you go through this paper, you will see it is speaking about all other papers, what they done and what result they got and all those stuffs, instead of they mentioning their own methodology. In their methodology, they say they have gone with stacked regression. That's all. They feel like only stacked regression can do the things better. That's all they are trying to mention. They are not saying, they are not mentioning what are the pre-processing stuff they did, how they cleaned the data set, and what are all the problems the data set was having, how to handle it. Nothing is being discussed in the paper. So that's why we are trying to keep those things. For example, in that paper they are saying cry algorithm by Anantara. Okay, this paper, what that is doing, what CRY algorithm they are doing, and how much accuracy they are getting. And the next paper, smart framework by Avan. So again, what this paper is concentrating on K-mean kernel. Okay, and fuzzy logic Chavla. And what this paper is again doing, based on rainfall and temperature only, they are trying to doing the research. And the next one is hybrid algorithm by Chaudhary. So this paper is again speaking about area, rainfall and soil type. And the models they are going with is hybrid K means a priori and Bayes algorithm. You can see these are all already existing papers they are studying, and they made a research analysis. We can say literature survey. In the next paper that we're gonna take is this crop yield prediction using machine learning algorithms. What does this paper contains? Okay, they are presenting the table, so we'll see what does that paper contain. Mainly, this paper is again like this paper is collecting multiple papers and it is doing literature survey. For example, Kumar, this paper's methodology is mainly they are concentrating on SUM. Advantage, that paper discuss it is a high accuracy in prediction. That high accuracy will come and stop at 97.77. Okay, precision 99.24, because here crop yield they done a classification, bad or good, like that. They are not saying how much particularly it will yield. Always you should remember what they are doing and what we are doing. If they are similar, then only direct comparison can be done. So Tiwari Shukla, again they have gone with this thing, and their RMS is very high. Their RMS is very high, and they are going with CNN. So you can see 1396.4 root mean square error is very high. In our case, we are having very low root mean square error, that is around 5, 4. And yeah, you can we'll be giving you all those documentation whatever we done after so much of research, and these things are exact values and data from each and every research paper that we are referring now. So once you present these papers, then only you can say, you can say and present how our proposed methodology is better than the existing one. So the last paper is that crop yield prediction using machine learning algorithms. So here in this paper also, they are trying to say what are the key features or input features available for their data set: temperature, rainfall, area, and season. And then what are the machine learning algorithms they are concentrating on: RNN and LSTM, because they are going to sequential data. Again, they are even trying with machine learning models, among them random forest, XGBoost, KNN, loss regression, linear regression, and ANN models. And what results they are getting? Around 81%. Okay, and mean absolute error 22.17. So for simple RNN, for LSTM, they are two different stuff, two different models. And again, this paper is having another part called crop name prediction also is there, and crop yield prediction. So there are separate things for that. In this particular paper, there are two things: mainly crop, which is crop recommendation, what you say, and the crop yield is there. And you can see we are referring the figures. You can see the figures in that paper, because we will be providing even the research paper. You can copy paste that image here itself, otherwise you can say figure 9 in that paper. Okay, so now whatever we discussed, first one is the introduction, and the next one is the existing system. Now what is our proposed methodology, so which is far better than the existing papers? So when you go through these papers, they are not much concentrating on the pre-processing. So under pre-processing, our proposed methodology is that we are going to clean the data set. If there is any null, we are going to handle it with the mean, median, and mode. That is the imputation, what you call. And after that, we will see the distribution of data. It means normal distribution thing, that also we can see. Otherwise, whether the data is having a lot of difference between the low value and high value, that what you call as outliers. The data which lies out of the mean value, there will be so much of points. For example, when you take agriculture crop yield will be, let us say, 2000 ton, 100 ton, 1900 ton, but suddenly there will be some locations which will be having 13,000 tons. For explanation, I am giving this example. So in that case, 13,000 is lot different from 2000. So in that case, our model's performance will reduce. So that's why we call them as outliers. The data, the value that is far away from the mean values. So those values will be selected and those values will be filtered. By doing this, you can able to increase the accuracies from minimum 5 to 10% of accuracy can be increased. So that what we are proposing in our model. And then when it comes to feature extraction, what type of features we are extracting? In the present existing papers, they almost only one paper is speaking about it clearly, and they are saying they are going to correlation. So in our case, what we can do better? In our case, we are going to propose a technology or the technique or the methodology is that we're gonna try wrapping technique, then we're gonna try lasso technique. Then when we tried wrapping, then we implemented model, we saw improved result. Okay, we saw a better improved result. And then we implemented lasso, there the result is improved, but it was little bit less than the wrapping technique. It won't happen always. Sometimes you may get better features selected by lasso, sometimes by wrapping technique. So we are trying all of them. We are having multiple codes for these. Okay, we are doing R&D. This is not a one-time coding stuff we are doing. we'll see all the results one by one, then we compare and then we say which is better and why that is better. Okay, so that is our proposed model comes under the feature extraction. Then models. So what are all the models that we are going with? How can we propose our own methodology which is better than the existing paper? That our concentration was mainly on boosting algorithms and bagging algorithms, as well as we are even building SVMs and all those linear regressions. But linear regression and all these are failing to give us a good result. The better result that we got is random forest. So in our case we used around 8 ML models, multiple machine learning models, not single model. Then we say which is better, which is not better for our problem statement, which is solving our problem statement in better way, which is giving us less RMSE, less MAE, mean absolute error, okay, root mean square error, that will be very less. So accuracy will be bit better. All those improvements, how they are being done for different models, after that only we will decide which is the best model. So instead of going only with the single model, we are going with the multiple models. In the multiple models also our concentration was with basic models like linear regression, SVM. We are trying to concentrate on bagging techniques as well as boosting techniques like random forest, decision trees, XGBoost, ADA boost, Kata boost, and light BGM, different models. So when we build different models, we can able to say which is better or not. So then you can take best model to your web application. So as we took our best model to the web application, and we have built a web page for the testing the application. So we will see this demo. Before that we will try to run our codes, Jupyter notebooks, then I will show you how we do that R&D clearly. So here you see we have multiple codes, implementation 1 2 3 4, because so proposed methodology first we will implement and we'll see what is accuracy, and then we go and we'll implement before correlation. Okay, what will happen before correlation, what will happen after correlation, whether by doing the correlation we are improving anything in the result than the previous stuff. So we will go one by one. Okay, this is a proposed methodology, and here we are removing the detecting and removing the outliers, and we are getting around 85 77 or like that. This is correlation one. So 60, this was less. Okay, so again correlation and all those things are there. So before correlation what happened, after correlation what happened, and then we go and we see wrapping technique, what happened after wrapping technique, whether their accuracy increased and how much it increased. So here you see, so 83, as well as you need to see one more thing, training MSc and RMSc, what impact is happening on this, whether again you don't need to decide only based on the training accuracies and all those things. You need to check even root mean square errors. Okay, root mean square error should be very less. And we gone with the lasso. So lasso was giving little bit less accuracy than the wrapping technique, as I mentioned. All those things we can show you. So you can see here 55%. It doesn't mean like every time lasso the features selected by using lasso will leads to less accuracy. It won't happen like that. Sometimes maybe lasso can able to give you a better result. That happened in my previous project. You can watch that video. We done agriculture crop price prediction video. Within that, actually the features selected by lasso were giving better result than the features selected by wrapping technique. And so this is a final one. where we implemented all these best features. Then we built multiple models. As I told you, multiple models we're gonna build. So this outlier detection and removal stuff. Yeah, and if you approach us, the whole code will be given to you. And also one more thing I need to present you, that we can change our methodologies according to your interest in future if you need it, according to your papers. If you want to write a new paper better than this also, you can propose and present the paper. So we can change our methodology according to your interest. Then we can build these things according to your interest. So as I mentioned earlier, you can see R2 score is 97% for the random forest. No model is going there. 44 for the ADA boost regressor. Linear regressor it will be 27%, which is very low. Yes, we are 38, and ridge regression 27, and lasso 26, LG boost so 77%, little bit better, light BGM. So like this, there are multiple models with the values, and you can see here XG boost actually it is doing 86%. So random forest and XG boost are in competition. So even you can see why the random forest I say better is, you see those RMS value, root mean square error value is 4.79, which is very low. So remaining models are having very high root mean square error. So that's why we are going with that. Even residual distribution curves also we are plotting. So if you are a PhD guy, or if you are a MTech guy, or even if you are from BE BTech also, you will be given a same code. It doesn't mean like we do a lot of research for MTech and PhD, and you may think we will not concentrate on BE and BTech. It doesn't go like that. Even though you are from BE BTech, the research will be done to the good level, and the data will be provided to you. Only you can do is, you can just WhatsApp to us. The number will be attached below in the description. You can call to us. You can directly call to us and discuss about the data sets, codes, or any improvements, further improvements or implementations. So whatever the service that we are providing, we will charge accordingly. Not a random pricing will be done, and we'll keep pricing almost to the uh, possible prices will be like everyone can access our service. Doesn't mean like we are keeping a random pricing over there. So now we can test our application. So here we'll first upload our dataset, then we'll see the basic information. What are all the basic information this gives is, it will try to provide us some head data frame, and then say how many rows and columns are there. It will describe about our data set. Okay, here description nothing but, for example, crop area, average area, you mean nothing but average. The average area in each district is this much. Standard, it means maybe some areas are having 500 hectares more, 500 hectares less, like that. Minimum 4 hectares, whatever, 400 hectares. 25% of locations the data collected is this much. So it is actually the mathematical explanation of the each column, how much data it contains, or what are all the data it contains. Again, info will give us one more important stuff, which column and what type of data it contains, object. And we need to handle it in our codes. We handle this when we have object type columns, what to do, what topic can be what methodology can be applied there to convert this into numerical, because you need all the columns should be numerical. You should not have anything in object type before you feeding that to a machine learning model, whether you go with a mapping technique to solve this, or whether you go one art encoding. So different techniques need to be tried, and which will lead to the better accuracy. And then pre-processing of the data. Under pre-processing, mainly we are concentrating on nulls. So normally in our dataset there are no nulls. So those nulls, if there were a nulls nothing but the empty values, those will be detected and they will be handled. So maybe if it is a numerical, we try to see if there are only few, we try to do by replacing with the mean. If there are a lot of data missing, then we try to remove them, because lot of data if you fill up with the mean, that will again leads to the problem or the issue. And if it is an object type or categorical column, we try to go with the mode. and EDA data. So this EDA data will give us the graphs. So those graphs can explain us about the few things. Mainly, first we try to do distribution graphs. And one more thing is, you can like when you try to take this project from our side, one extra support that we will do is that once you take this project, we will help you whenever you want. For example, when you take this project and after a few days your lecturers may ask for the changes in the project. Maybe they want you to improve something. In that time you don't need to feel like you are stuck. You can approach us because we will do the mentorship. Under the mentorship, we can able to help you with the small possible changes or improvements, or even whenever you want, you can just let us know for you need any classes for explanation. In case after possible classes you have any doubts, so those doubts can be clarified. So this EDA data and EDA data too, they will take a little bit more time. The reason is very simple. We are having 2,46,000 of rows of data, so it is bit time taking. Otherwise, I will be on, yeah, I will be waiting for that. Okay, once that graph will come, I will explain. So you can see this distribution curves. For example, if we take temperature and count around 310. Okay, so around 310 it is not a Celsius. Okay, and yeah, around 310 it is Fahrenheit, I think. So around 310 the more data are there. Around 310 only there is a lot of locations which are having this temperature, and below this we are having less temperature. When you take wind speed between 2 to 3, there are a lot of locations where the wind speed is between 2 to 3, and after 3 and below 2 there are less locations they where that wind speed is there. When you take precipitation as also, almost most of the locations are having a rainfall uh, between 1010 to 1020. They are around 800 locations or more. Okay, there, this will give us the count, the distribution, how the data is being distributed. If you take humidity, the humidity in which range there are more locations is that around 60. Around 60 there are more locations which are having the humidity. That value humidity 60 humidity is most distributed over the data. Same thing will happen for the categorical columns. What if categorical columns and how they are being distributed? So kharif region, more crops are being grown in kharif region, then whole year, summer, winter, so less crops are being grown in a winter, summer. So this distribution is given by these graphs. They are normally distribution curves. Finally, we can able to see correlation heat map. So it will give us the relation between the two variables, how they are correlated, and how one parameter is impacting on another parameter. For example, say area, one second, we'll say pressure and temperature. They are completely reverse. You can see the mouse, okay, pointer minus 0.44. It means if temperature increases, pressure decreases. If pressure increases, temperature decreases. So like this, there is a relation between all of them. So how the relations are, that is being given by the probability. If it says a minus, it means it is in opposite direction. It doesn't mean minus 0.44, because no probability value will lie between 0 to -1. All the probability values should be from 0 to 1. If there is a minus, it will happen in reverse. Okay. Okay. Now upload our data set. Then we are going to see EDA data too. Here few graphs will be now plotted, and they will also give us the meaningful insights. So the first one is violin plot. Violin plot gives us how the production is distributed. So all these multiple graphs are there. These are all rel plots actually. It means how area and productions are related. When the area increases, the production level also will increase. And when it comes to area and this one with the line, okay, with line and scatter we are doing. Okay, the above one is scatter, the below one is line. And temperature, how temperature impacting on the production. And finally how precipitation is impacting on the production, which precipitation part will give us the best production. So all those analysis we call them as a rel plots or relational plots. The above one is actually violin plot. Finally we need to build the models. So we'll click on the models data. So it will give us, it will try to build three models, three different models. But in the backend we saw that Jupyter notebooks we built already multiple models. Close them. It will take a bit time. You can see the model parameters that we got now. One is random forest, which is giving very good accuracy 98% and testing 93%. As well as you can go with some other models where linear regression is failing to do. Again, XGBoost is very good. It is competing with even random forest regression. So only three models here we are printing, but remaining parameters are remaining model parameters can also be printed here, whatever we do in the Jupyter notebook. So combining all of them together will become around more than 8 machine learning models together. And after that we'll take the best model. In our case, as we discussed, is the random forest. That is the best because that was having low RMSE as well as good accuracy. So we're gonna test our application. So first, here you can select any state name, district name, crop year. So I'm going with Andaman Nicobar itself, and crop year I will take 2024. Season maybe Kharif. Crop I can change because there will be a drop down. You can change according to that. Area, let us take 3 hectares are there. Temperature Kelvin 304 and wind speed 4 knots, 4.5 knots, a little bit. And precipitation, let me take 44, some random values I'm trying to consider. And soil type, let me take sandy. Nitrogen 23, phosphorus 0, potassium for now I'll take 0, and pressure 1004. So when I click on the prediction I will be getting like this. Okay, so this many tons you will get for the production or like that. So you can change anything here. Okay, so we can change state. There are so many states available. Okay, you can change according to that the district of that state. Okay, and you can change year. For now 2024 you can try. Season, multiple options are there: whole year, autumn, rabi, summer, winter. As well as for area, you can start from 1 hectare. And temperature, wind speed, precipitation, humidity, soil type. Again under soil type we are having clay, sandy, peaty, chalky, silt, silty and loamy. So nitrogen, phosphorus and potassium content of the soil as well as the pressure in the atmosphere. So these features, I think when we gone through multiple research papers, that is IEEE papers, so there nowhere you saw these features. And one more stuff, they mentioned that they used soil parameters and weather parameters, but no paper is giving in detail what are the parameters are there and how they are being used. You can see this is our data set. This is our data set which contains lot of information. So over this data set only we are trying to build our model. That data set is having around 2 lakh, more than 2 lakh 40,000 rows, which contains almost all districts of all state of India. So this is mainly crop yield prediction based on the Indian agriculture data. You can try with some other data also. Okay, you can go with Andhra Pradesh. You can go with any district of Andhra Pradesh, Guntur, and you can take crop year 2024 and crop. Let us take rice, and area. Let's take per hectare. Temperature. Let me take little bit more. Wind speed 2 knots. And precipitation. Let me take 619. Some number you need to take, maybe 44. Maybe humidity I will take 154. Soil type I will take chalky. Okay, and nitrogen I will take around 45. Phosphorus 0. Now potassium I will take 23. And rainfall pressure 1 2. Some random value which is very high. Okay, some values. Then you see the prediction is done. Okay, maybe because of a lot of temperature that we increase the temperature, that may be leading to the reduction of the crop yield for the rice for the different location. So like this you can detect for any state and any district and any condition. You can get all the parameters and you can implement it here and you can get the result, because we are getting bit good result. And yeah, when you feed it to the model, and when you get the prediction, you'll get the result properly. And as I mentioned, we built front end and back end. For the front end we use the HTML CSS. For back end we are using Flask. So, and we little bit use JavaScript also for the front end. So all together this is in a complete full stack web app using machine learning. So which contains all the parameters, the website that you already saw just now. Okay, so just like that, we have so many codes, EDA pages, okay, index pages, model detail pages, okay, mainly app.py, which contains the Flash code. So everything will be provided to you, each and everything will be provided to you if you approach us through our WhatsApp, or you can directly call us. So we'll be giving you almost all the data that we done R&D. And yeah, we will price accordingly. So we will discuss with you what you want, what you don't want, because the level of student that approach us will not be same. I mean, you won't be taking the project as it is. Almost you'll be having your own requirement. You want to reduce the requirement, you want to increase the requirement based on what you are studying. Maybe sometimes sometimes BTech, sometimes MTech and PhD guys, they will be having little bit in the implementation idea. So accordingly we need to charge. So if you approach us, if you discuss what you want to implement and what you want to change, according to that we'll implement and give. We even try to provide you the complete documentation, raw documentation, that will contain introduction, abstract, methodology, and conclusion, result analysis, references, literature survey. So you can use that information and you need to restudy, okay, if you want, and then you can write your own reports. Then you can prepare for your presentations, and also you can write even papers, because if you are coming with your own idea, little bit changes here, that will be a new idea and that will be implemented, and you can write even the papers according to your interest. So this was all about today's video. If you watched a video till now, please don't forget to subscribe and like our channel. Thank you very much for the support. We'll see in the next video with the great uh, idea. We will implement it and we'll discuss better about that. Thank you very much.